Now let's learn about engineering approaches to airborne infection control. Infections spread from a reservoir to a susceptible host through three modes of transmission: contact transmission, droplet transmission, or airborne transmissions. If you want to change the if you want to break the chain of infection, one has to break this mode of transmission by following proper isolation precautions. If you see the difference between the airborne and the droplet infection, in airborne infection, the particles are less than 5 microns in size, while in droplet, the particles are more than 5 microns. Spreads more than 3/4 distances, while spread less than 3/5 distances. Suspended for longer duration, suspended for lesser duration. N95 respirator, mask, and negative ventilation is required, while here only mask is required. Examples are diphtheria pertussis, while examples of airborne infections are tuberculosis and measles. When a person coughs, about 0 to 200 organisms are released into the air. While when he coughs, about thousands of organisms are released into the air. While sneezing releases about nearly lakhs of organisms into the air. The size of a droplet in sneezing is about 3 to 10. While 75% are nearly 10 microns in diameter, while less than 25% are droplet nuclei. They are less than 5 microns in diameter. Now, what to do in such cases when there is so much crowding, and how to follow the airborne and droplet precautions? Anyone can be having an airborne infection and a droplet infection. So here we require managerial controls, administrative controls, environmental controls, and personal protective protection for airborne infection control. Where managerial control is to develop a facility plan, administrative control is to have a reduced potential opportunities for exposure, environmental control aims to reduce the concentration of infection particles, while personal respiratory protection is to reduce the further risks by wearing N95 respirator. So the controls needs to be applied in indoor patient segregation and bed spacing to ensure effective ventilation at all times and season. Ventilation is more effective if airflow from the clean to contaminated, and there is a good mixing and no stagnation of air. Special attention needs to be given for high risk areas and proper sitting arrangement. The types of ventilation are natural ventilation, mechanical ventilation, and hybrid ventilation. And the three basic elements of ventilation are ventilation rate, airflow direction, and airflow pattern. Terms of ventilation. Ventilation moves from outdoor air into a building or a room and distributes the air within the building or room. The general purpose of ventilation is to provide healthy air for breathing by both diluting the pollutants originating in the building and removing the pollution from it. It has three basic elements as said before: rate, airflow direction, and distribution. Amount of outdoor air that is provided into space is the ventilation rate. The direction in the building it should be from clean to dirty, and distribution should be such that the external air should be delivered to each part of the space in an efficient manner, and pollutants generated should also be transmitted in an efficient manner outside. Ventilation performance in buildings can be evaluated from four aspects. Does the system provide sufficient ventilation rate? Is the overall direction from clean to dirty areas? How efficient is delivering the outdoor air to each location of the room? How efficient is the system in removing the pollutants from each location of the room? Locate the healthcare worker near the clean source. Locate a person who may be infectious near a place where the air is exhausted away. So this is how the correct location should be. The healthcare worker should be should be near the place where the wind is coming, while patients should be near where the wind is exhausting. So the airflow should be from clean to dirty, and not if it is there, the resolve was switching places so that the healthcare worker is near the clean air source. There can be good compromise if we keep the airflow in between the patient and healthcare worker too. So the purely exhaust fan in an open window with short circuiting of the airflow is an incorrect. Airflow should be like a negative pressure. It should be recommended in high risk settings where TB and other such respiratory diseases are managed. To summarize, air change rate ensure adequate airflow and minimum flow specification are made. Approximate measurement under all weather and building operation conditions should be made. Air distribution should be from clean to dirty. Flow of infection agent directly out of the building should be ensured. Avoid flow towards the patients and have proper management plan. Your patient has interest in life in your hands. Thank you.